right. Oh, good. All right, guys, so we're going to go over the review video. I'm going to go through the whole review video here. Now, the first one we're looking at is problems 1 through 8, interval notation. With interval notation, we're rewriting these inequalities with parentheses and brackets based off the endpoints. So if we look at number 1, we're saying negative 256 is less than x is less than or equal to 100. Now, because we do have two definite endpoints, which is negative 256 and 100, we will have those. Since it is less than or equal to 100, the equal would be a bracket, and since it's not equal to 256, it just has a parenthesis, because the bracket is with equal to, parentheses is not. Now number 2 says x is less than 200. So 200 is the biggest value we can have, and we'd have a parenthesis because it's not equal to it. And now it'll be every number smaller than it. But because it's continuously going indefinitely smaller, our smallest number is going to be negative infinity. And it will have a parenthesis because positive and negative infinity both will have parentheses. Now number 3, x is greater than or equal to negative 174. So negative 174 would be the smallest, and it is included. And since it's talking about all the numbers bigger than it, we're going to go to positive infinity. Now number 4, again, we have two endpoints, 6 and 247. And because it is told to us that they are equal to both of them will have brackets, so we have this here. Now with any of these here in the next 4, the smaller number is always on the left, and the bigger number is always on the right. Now if we look at this one here, 6 is less than or equal to x. X is the bigger one. So that means 6 is the smallest value we can have, and it's going to go to infinity. 6 would have the bracket, infinity would have the parenthesis. Now if we look at number 4, x is greater than 4. 4 is the smallest number. It's going to go to infinity, and they would have both have parentheses because it's not equal to, and we cannot have a bracket with infinity. Negative number 7. We have two endpoints. So we'd have 96 and 100, and since it's not either equal to either of them, we would have two parentheses. And lastly, 9 is greater than x, or x is less than 9. So the biggest number we can have is 9. Smallest number we can have is negative infinity, and we'd have two parentheses. Now, set builder notation is not going to be something that is going to be bonus questions on the test. So I'm going to specifically do 9 and one more. So we'll look at 9 first. I'm not going to look at 10. 9, the first thing we have to do is rewrite this as an inequality. So we do have two endpoints, and x is going to be in the middle. And we'll have our signs. Now, x is equal to 87, so we get this here. Now we'll have our x bar, this, and then this is our final answer. The other one I want to look at is number 11, the set of all real numbers except for negative 2. So we'll have brace x bar, because that's just saying the set of all real numbers except negative 2. So we're saying x is not equal to negative 2. And that's it. Now I'm not going to worry about the rest of those there. It's not going to be important, especially on the test. For problems 15 through 18, solve each of the following systems of equations by any method. Now, you don't necessarily have to do one by hand. That was for the bonus on previous tests. It's not for this one here. It may be included later, but this test for 2023, it will not have it. So we could do these by hand. And if we did this one by hand, we would pick a variable to eliminate. I'm going to eliminate y. And then I need an eliminator equation. I picked the bottom one. So the first thing I'm going to do is rewrite the other two equations. So negative x minus 5y minus 5z equals 2. 4x minus 5y plus 4z equals 19. Then I'm going to write the eliminator equation underneath. Now luckily for this here, I don't have to change anything because the value for y is already the same in both, so I don't need to do anything there. Now since the signs are opposite, we will add the two equations together in both regards. And when we add, for the first one, negative x plus x is 0. Negative 5y plus 5y is 0. And negative 5z minus z is negative 6z. And 2 plus negative 20 is negative 18. Now luckily for us, z is by itself, so we can just go on and solve, telling us z is 3. Now we can do the same thing for the other equation. 4x plus x is 5x. Negative 5y plus 5y is 0. And 4z plus negative z is plus 3z is equal to negative 19 plus negative, or 19 plus negative 20 is negative 1. Now at this point here, we can plug in the value of z. So a 5x plus 3 times 3 equals negative 1. So we have 5x plus 9 equals negative 1. At this point here, we can subtract 9 from both sides, telling us 5x is equal to negative 10. Divide by 5, telling us x is negative 2. And last but not least, we can plug this back in to find y. So we'd have negative 2 plus 5y minus 3 is equal to negative 20. We combine like terms, we get 5y minus 5 is negative 20. At this point here, we can add 5 to both sides. Telling us 5y is negative 15. Divide both sides by 5, telling us y is negative 3, which means our solution is the point negative 2, negative 3, 3. And that's it. Now the other way we could have done this is with systems, or using the calculator to solve. And if we did that, the first thing we can do is write the augmented matrix. There's the augmented matrix for this here. It'd be negative 1, negative 5, negative 5, 2. And we have 4, negative 5, 4, 19, 1, 5, negative 1, negative 20. Now this is indeed a 3 by 4, because we have 3 rows and 4 columns. And now we can plug it into the graphing calculator. Now when we plug this into the graphing calculator, the first thing we need to do is type the matrix in. So we're going to go second matrix, over to edit. Now it is a 3 by 4, and we'll type the matrix in. So we'll have negative 1, negative 5, negative 5, 2, 4, negative 5, 4, 19, 1, 5, negative 1, negative 20. Now we have the whole matrix typed in. The next thing we're going to do is second quit. And after we do that, we need our REF. So to get that, we'll go back to second matrix, go over to math, and we're going to go down to our REF. And lastly, we need to recall the matrix we plugged it in. So we can say our second matrix enter, since I plugged it into the first one, and enter one more time, and we get this here. The top number in the last row is x, the middle is y, and the last one z. So we have negative 2, negative 3, 3. And if we look back to what we did by hand, that's what we got here. Okay, now what we're going to do next is look at the next problem, 16. Now we can do this by hand again, or we can do this in the calculator. Either one works. I'm going to go on and do this one in the calculator. Because again, if we do this in the calculator, the first thing we need is the augmented matrix. So negative 4, negative 5, negative 1, 18. Then we have negative 2, negative 5, negative 2, 12, negative 2, 5, 2, 4. And again, this is a 3 by 4. The first thing we can do is grab the graphing calculator, and we need to put the matrix in. So we'll go second matrix over to edit. It is still a 3 by 4. This time we have -4, -5, -1, 18, -2, -5, -2, 12, and then -2, 5, 2, 4. And after we get it all typed in, we can go second quit. Now again, we need RREF, so we can go second matrix, over to math and find RREF. Now that we have this, we need to recall the matrix to it. So we'll go second matrix, and we pick the correct one out of this list, which is A. We can enter, and this is our solution, -4, 0, -2. So the answer is -4, 0, -2, and we do need to list the answer in this form here as an ordered triplet. Now we can do the same thing for 17 and 18. So we'd write our augmented matrix and we get this here. 3, -3, 4, -23, 1, 2, -3, 25, 4, -1, 1, 25. And again, we can grab the calculator and say second matrix. Go over to edit. It is still a 3 by 4. But this time we have 3, -3, 4, -23. 1, 2, -3, 25. 4, -1, 1, 25. Second quit. Second matrix, go over to name, or not name, math, RREF. Second matrix, we'll select matrix A and hit enter. Now if we do have decimals, we can go math, enter, enter, and it will change them to fractions. But the main thing is the last row, the 0, 0, 0, 1, is telling that this is a no solution. Because that last row of all zeros and a 1 is telling us that we have 0x plus 0y plus 0z is equal to 1, or 0 is equal to 1, which is not a true statement, so it is no solution. And again, on my test, I do not put no solutions on the test, so this will not show up. And the last one, 18, of this type, we'll need to write the augmented matrix. We have this here. And now that we have this, we can go on and type it into the calculator. We can go second matrix. Over to edit, we'll edit matrix A, which is still a 3 by 4. So we have 1, 1, 1, 2, 1, 1, -1, 2, and 2, 2, 1, 4. Now at this point here, we can go second quit. Now we need the RREF to solve this here, so we'll go select it first. Now we'll need to recall matrix A. Hit enter. Now if you notice that the last row for this here is all zeros, which means that this is infinitely many solutions. Infinitely many solutions. And that's it for those there. Now 19 through 24, we want to write the augmented matrix and state the dimensions. So the augmented matrix is essentially what we were doing before we plugged them into the calculator, and for these here. Now with writing the augmented matrix, we need to make sure the variables are in order and all are listed. For 19, both equations do have x first, y second, and then the number without a variable, our constant term, is on the other side. So for the first row, we would have 7, -41, 29. The second row, we'd have 46, -2, and 19. Now, since there are 2 rows and 4 columns, we'll call this a 2 by, not 4 columns, 3 columns. 2 rows, 3 columns, it is a 2 by 3. So this is our final answer for this one here. Now the next one, we look at this here. So the first one does have x first. It does not have a y, and we'll counter that later, but then z and a number. The second one is out of order. X and y need to be switched, but the last one's fine. So if we flip the middle row, it should be negative 7x plus y plus 4z is equal to 15. It's an easy change. Now that we have that set up, we can go through writing this out. Now for our first row, we would have 6 for x. Now because there's not a y value, we fill it in with 0. If it's not there, we fill it in with 0. Now the z value is 4, and it's equal to 2. Now we can move on to the second row. We'll have negative 7 for x, 1 for y, 4 for z, and then 15. In the last row, we have 6 for x, negative 1 for y, 3 for z, and 20. Now this one does have 3 rows and 4 columns, so we'll call it A3 by 4. And that's our answer for 20. Now we can look at 21. We do have x, we do have y, and they are in the correct order. So our augmented matrix should be 11, 4, 2, 6, negative 3, 7. And this one here is A2 by 3. The next one we have is 22. Now in all three equations, x, y, z are written in the correct order, so we can go on and just write it. So we'd have 6, negative 2, 3, 1. Our next one's going to be 9, 1, 9, 9. Our last one, 1, negative 21, 1, 4. And we get this here. Now we do need the dimensions because it does have 3 rows and 4 columns. We would call it A3 by 4. And that's it. It's not asking us to solve, it's just asking us to write the augmented matrix and state the dimensions. 23. We do have 2 equations. They are written in the correct order, so we can go on and write the matrix. So we have 6, negative 1, 6. Our next one would be 2, 3, 9, and this here would be A2 by 3. And our last one. Now the first equation, x, z, they are written in the correct order. The middle equation, x, y, z, and the last one, y, z, they are written in the correct order. We just have to fill in some for the missing variables. So for the first row, we would have 6 for x, but because y does not show up, it would be 0. And we'd have negative 1 for z and 2. The next row does have all 3, so we'd have 9 for x, 1 for y, negative 1 for z, and then 14. And the last one, we don't have an x value, so we would fill it in as 0. 1 for y, 9 for z, and it's set equal to 3. And this here is A3 by 4. And when writing these here, we do have to include the variable if it's included in one of the others. Transformation. Now with the transformations, I did include a list of them on the board. I'll rewrite them out here because our vertical translation, well, these are all our transformations, is given to us by the formula f of x plus k. This is our up or down. Our horizontal translation is our f of x minus h, which is our left slash right. Our reflection across the x-axis is our negative f of x. And our reflection across the y-axis is our f of negative x. The last two is vertical stretch and shrink. which is going to be our a times f of x, and our horizontal stretch slash shrink is our f of a of x, and for this one here we have to flip the value of a when we talk about horizontal. So when we look at this first one here, translated up 3 and a vertical stretch of 2. So the first one, if we have multiple, we do the translation up 3. So for up 3, we're talking about f of x plus k. And for us here, our k is 3, and since it's up, it will be positive. Now, since we still have f of x, we're just going to replace it with its function, 6x squared minus 1. We didn't do anything to the x inside the parentheses, it's still just x. So we just replace it, and we have plus 3. Now at this point here, we can drop the parentheses, telling us that we have 6x squared minus 1 plus 3. And lastly, we can combine like terms, telling us that we have 6x squared plus 2. So this is our new function, and we can call this g of x. Now, they didn't say we were done because they said, and a vertical stretch of 2. So we need to apply that vertical stretch to our new function g of x. So our vertical stretch of 2 is our a f of x, but now we're going to apply it to g of x, so we'll say a times g of x. Well, the value of a is 2, so we're multiplying g of x by 2. So this entire part of the function by 2. So I replace g of x with its function, 6x squared plus 2, and we distribute through. So we'll do 2 times 6x squared and 2 times 2. Well, 2 times 6 is 12, and we still have the x squared plus 4. And this is our final function. Now, we can name it. We can give it a name. I saw that there. Well, we can just call it h of x. And that's it. And whenever we do more than one transformation, we do each one at a time and go from there. What we call it isn't as important as what we do or apply it. Now 26. Translation 4 units right and up 3. So we'll do the 4 units right first. Now our left and right is going to be our f of x minus h. Well, it said right 4, so the value of h is positive 4, but that ends up giving us x minus 4. Now, unlike the last one, we do have something different inside the parentheses, which means I replace this x with x minus 4, which means I'm going to replace every x in the function with x minus 4, which tells us we're going to have 2 times x minus 4 minus 1. Now we do need to simplify, so we'll distribute the 2. 2 times x is 2x. 2 times negative 4 is negative 8 minus 1. And lastly, negative 8 minus 1 is negative 9. Now at this point here, this is our new function, and we can call it g of x. Now that's not the only thing we need to do. We also need to take it up 3. So for our up and down, we add k. And we're applying it to g of x because that's the new function we have. We're applying it to g of x, not f of x. And our value of k is 3, and it would be positive. So we have plus 3. Now g of x, we will replace with its function, which is going to be the absolute value of 2x minus 9 plus 3. We can drop the parentheses because we're not multiplying it by anything. And this is our function. Now, if we really want to name it, we can name it h of x. And we get this here. Let's look at 27. Translated up 3 and reflected across the y-axis. So the first thing, again, we do them in order, is translated up 3 units. So we'd have f of x plus k. Now for this one here, our value of k is 3, and since it's up, it will be positive. Since we still just have f of x, we can replace it with its function. We'll have 6x minus 1 plus 3. Now, since there's nothing in front of the parentheses, we can go on and drop them and then simplify, telling us that we have 6x plus 2. And this is our new function here. Now, again, we still need to reflect it across the y-axis. So using the forms that we have, our reflection across the y-axis is going to be our g of negative x, because again, with these here, I'm referring back to these forms, one of these here. And a reflection across the y-axis, f of negative x, we could say g of negative x, they are the same thing. Now, at this point here, every x in g of x is going to be replaced with negative x. So we have 6 times negative x plus 2. Well, 6 times negative x is negative 6x plus 2. This is our new function, and that's it with that there. Let's look at 28. Reflected across the x-axis, then translated up 4. Well, reflected across the x-axis, starting form is negative f of x. Well, we didn't do anything inside the parentheses, so we're just going to replace f of x with its function. So I have parentheses, absolute value 4x minus 3 plus 2. Now this time, unlike the others, we have the negative in front. We'll have to distribute it to both. Now the negative does not go inside the absolute values, so we'll just have negative times the absolute values. And negative times positive 2 will make it negative 2. So that'll give us our new function after it's reflected across the x-axis. Now the second part is to translate it up 4. So our up 4 would be g of x plus k. Now our k value in this case is 4, and it would be positive because we're going up. At this point here, we can replace g of x with what it's equal to, and we still have the plus 4. Then we can drop the parentheses and combine like terms. Tell us that we have negative absolute value 4x minus 3, and our negative 2 plus 4 gives us plus 2. We can call this h of x. $29 is our next one that we're going to look at. Translation left 7 and reflected across the x-axis. So translation of 7 left, so again, we're using f of x minus h. Now this time our h value is negative 7 because we're going left. But our negative negative makes a plus, and we get this here. Now because we don't have f of x anymore, we have f of x plus 7. Every place that there's an x needs to be replaced with x plus 7. So we still have the 5, but instead of x, we have x plus 7. All the rest of the function's still there. We're just replacing x with x plus 7. Now at this point here, we can distribute the 5. Well, 5 times x is 5x. 5 times 7 is going to be plus 35 minus 1. And if we combine like terms, we get 5x plus 34. And we can call this our new function. Now the other part is reflected across the x-axis. Now according to our setup and start types, we're going to do negative g of x. We have a negative out front. Now since we didn't do anything with the x inside of g of x, our new function down here, we can replace g of x with its function, 5x plus 34. At this point here, we would distribute the negative, telling us that we have negative 5x minus 34. And that is our new function. Our next one, we have two more of these transformations, and that's this one here. Now this one we have three, a horizontal translation 4 units left, vertical shrink of 1/3, and a horizontal stretch of 4. Now we'll do them in order. So first one, horizontal translation 4 units left. So this will have f of x minus h. So 4 units left, well h will be 4, but it would be negative because we're going to the left. Well, our negative makes a plus. So we have f of x plus 4. Well, in our original function f of x, we replaced x with x plus 4, which means this x in the equation must also be replaced with x plus 4. Everything else will stay the same. So we'll still have the 2 absolute value, but instead of x, we have x plus 4, in parentheses, minus 3. Now we can drop the parentheses and get this here, 2 times the absolute value of x plus 4 minus 3. And if we combine like terms, we get 2 times x plus 1. So that takes care of the first translation, 4 units left. Now the next one's a vertical shrink of 1/3. Now our vertical shrink is a times our function, so a times g of x. In our case here, our vertical shrink is 1/3, so the value of a is 1/3. Now because we still have g of x, we can replace it with its function. So we'd have 1/3 times 2 times the absolute value of x plus 1. Now at this point here we can distribute, and since there's only one term, we'll multiply the 2 and 1/3, giving us 2/3 times the absolute value of x. And at this point we can call it h of x. What we call it is not truly important, it's just making sure we do the right steps. So that one's done. And the last one is horizontal stretch of 4. Now horizontal stretch and shrink would be our a of x inside the parentheses, and since we're applying it to h of x, we'll say h a of x. Now with horizontal stretch or shrink, we have to flip it. So since it was 4, we flip it to 1/4. So we'll have 1/4 x. Now again, just like some of the previous, especially the start of this one here, we don't have x anymore inside the parentheses. We have 1/4, which means every x in the function has to be replaced with 1/4 x. So what that tells us is that we have 2/3 absolute value. Instead of x, we have 1/4 x plus 1. Everything else stays the same except x is switched out for 1/4 x. So what that tells us in the end is that we have 2/3 times the absolute value of 1/4 x plus 1. And at this point here, we could use b of x. We're just giving it another name. We can't use g of x or h of x or f of x because all three of those have been used. So I just chose b of x. And that's it for number 30. Lastly, number 31. Vertical stretch of 3. Horizontal shrink of 1/4. In translation, 6 up and 4 left. So we've got 1, 2, 3, 4 translations, and we're going to do them in order. So vertical stretch of 3. So that'd be a times f of x. Well, our a value is 3 times the function f of x. Well, I still have f of x, which means I'm just going to replace it with its function. So I have 3 times 6x squared minus 2. Now before we can move on, I do need to distribute the 3. 3 times 6 is going to be 18. X squared. 3 times negative 2 is negative 6. And we can call this g of x. So we did our first translation, vertical stretch of 3. Now the next one we have is a horizontal shrink of 1/4. Our horizontal stretch or shrink is our a of x inside the parentheses. And since we're applying it to g of x, we'll say g a of x. Now before we can apply it again with horizontal stretch or shrink, we have to flip it. So it changes it from 1/4 to 4. So our value of a is 4. Now this one here, just like the previous ones, we changed x to 4x, which means every x in the equation has to change to 4x. Yep. So when we rewrite this back out, we'll still have 18, but instead of x inside the x squared, because that is inside the square, we'll have 4x squared minus 6. Now, I'm not requiring you to simplify this further from here, applying the square to both terms. We can leave it as this here. We can call this h of x. So I've now officially applied the horizontal shrink. Now that brings us to our next one, translation of 6 units up. So up and down is our plus k, so we'll have f of x plus k. Now since it's 6 units up, it's going to be plus 6. And we use h of x because we're applying it to this function here. So at this point, we can replace h of x with its function. 18 parentheses 4x squared, or x parentheses squared, minus 6, all in parentheses plus 6, because that's our h of x. Now at this point here, we can drop the parentheses, which gives us 18 times 4x squared, minus 6 plus 6. Well, if we combine like terms, we're just left with 18 times 4x squared, because our negative 6 plus 6 is 0. We get this here. And we can call this a of x. It doesn't really matter. We just need to pick a way to name it. And lastly, left 4. And left 4, the last one we're going to do. Put this here. And when we do this here, left 4, so we have a of x minus h. Actually, I'm not going to name it a. I want to pick something different, because that might be a little confusing. Let's name it c in this case. So c. C of x minus h. Now our h value in this case is 4, and since it's to the left, it would be negative 4. Now the negative negative will make a plus, so we have c of x plus 4. Now to replace that there is an x in our c of x, it has to be replaced with x plus 4. We'll still have the 18. We still have the 4, but instead of x, we have x plus 4 squared. Now this one here, we will need to distribute the 4. 4 times x is going to be 4x. 4 times 4 is plus 16 squared. And this is our final answer. If we want to name it d of x is equal to 18 times 4x plus 16 squared, we can. And that's it. That's all we have to do for this here. And if there was another translation after that, we would just continue on from there. And that brings us to our matrixy operations. The first one's scalar operations. When we do scalar operations, especially if we do it by hand, we're multiplying each element by whatever the scalar is. So here we're multiplying each one by 1/4. So we do 1/4 times 16. 1/4 times 24. 1/4 times 30. And lastly, 1/4 times 9. And if we do these here, well, 1/4 times 16 is 4. 1/4 times 24 is 6. 1/4 times 30 doesn't fully simplify, and we can plug that in. And if we plug that in, clear that out, 1/4 times 30 is 15/2 or 7.5. Either works. So we could say 7.5 or 15/2. And lastly, 1/4 times 9 is 9/4 or 2.25. And if you make one of them into a fraction, you need to make them all into a fraction. Now we could also have done this in the graphing calculator. If we wanted to do it in the graphing calculator, the first thing we need to do is plug the matrix in. So this matrix is going to be a 2 by 2. So we'll say 16, 24, 39. Once we get it plugged in, we'll go second quit. Now we're multiplying it by 1/4, so I need 1/4 first. And to do a fraction in the graphing calculator, we do alpha y equals enter 1/4. And then we do second matrix, recall the matrix that we have A. So 1/4 times A, which is this here. 4, 6, 15/2, 9/4. And again, having them both as fractions or both as decimals will work. The next one, we can do our subtraction of the first two and add the third into it, or we can do them one at a time. So if we subtract the first two, we subtract corresponding elements, so 2 minus 1. Then we'd have 7 minus 4. Our next one would be 9 minus 16. And lastly, 8 minus 27. Well, 2 minus 1 is 1. 7 minus 4 is 3. 9 minus 16 is -7, and 8 minus 27 is -19. And we're going to add to it 3, 8, 7, 2. Well, 1 plus 3 is 4. 3 plus 8 is 11. 7 plus -7 is 0. And -19 plus 2 is -17. So we get this here. Now we can also do this in the calculator. If we want to do it in the calculator, the first thing we need to do is plug the first matrix in. So it is a 2 by 2. We have 2, 7, 9, 8. And once we get that plugged in, we'll go second quit. Now this time, we need a second matrix. So I'm going to go down to B. And again, the second matrix listed is a 2 by 2. And it's 1, 4, 16, 27. Second quit. Second matrix, there's a third one. And we'll call this one matrix C, which will be a 2 by 2. And it's 3, 8, 7, 2. And lastly, we'll do second quit. So what I've done for this here is label this as A, B, and C. And we're going to do A minus B plus C. So when we type it in, we're going to go second matrix A minus second matrix B plus second matrix C. Enter. 4, 11, 0, -17. We get the exact same thing. So we can do it either way. And whenever we plug them in, so like 32, I can say that this is A, this is B, and this is C. And when we type it into the calculator, we'd say 2A minus 4B plus C. So if I do this here, we can go second matrix A, which is a 3 by 1. We can call it 3, 1, 4. Second quit, second matrix B is also a 3 by 1. 8, 6, 7. Second quit, second matrix C is also a 3 by 1, which is 3, 3, 3. Second quit. Now to solve it, we'll do 2 times matrix A minus 4 times matrix B plus second matrix C. Enter. And we get this here, -23, -19, -17. And that's our answer. And that brings us to the next one, this one here. Now again, for us to be able to add or subtract matrices, I didn't say this earlier, the dimensions have to be the same. Well, here we have a 3 by 3 subtracted from a 3 by 2, so this is not possible. I will not put no solutions on the test, but I will put one of these here, possibly. Put a not possible with a matrices addition subtraction. So I would be looking out for that. And lastly, we have these here. And again, we can go and just plug these in. So I can grab the calculator and do second matrix over to edit. This is a 2 by 4. So we have 8, 6, 21, 7, negative 31, 15, 9, 8. Second, quit. Second matrix over to edit. Edit matrix B and say it's a 2 by 4 as well. If it wasn't, we would not be able to add or subtract these two from each other. And we get this here, second quit. Now it told us we want to do 5 times matrix A and subtract from it 6 times matrix B, which gives us this here. Now we could have done this by hand. The first thing I would have done is multiplied the first one by 5. So we'd have done 5 times 8, which is 40. 5 times 6 is 30. 5 times 21 is 105. 5 times 7 is 35. 5 times negative 31 is negative 151. 5 times 15 is 75. 5 times 9 would be 45. And lastly, 5 times 8 is 40. So we have all these here, minus. So in this case, I'm just going to multiply with the 6 and then subtract later. So the first one we want to do is 6 times 18. Well, our 6 times 18 is going to be 108. 6 times 4 is 24. 6 times 6 is 36. 6 times negative 2 is going to be negative 12. 6 times 21 is 126. 6 times 15 is going to be 90. 6 times negative 18 is going to be negative 108. And lastly, 6 times 7 is 42. Now at this point here, we can subtract these from each other. So we can say 40 minus 108, which will be negative 68. 30 minus 24 is going to be 6. 105 minus 36 is going to be 9. Carry the 1, 3, 4, 69. 35 minus negative 12 would give us 47. Now that moves on to the next row. Negative 151 minus 126. 7, 7, 2, negative 277. 75 minus 90 is going to be negative 25. 45 minus negative 108, we would end up adding those, which would give us 153. And lastly, 40 minus 42 is negative 2. And if we look at this here, it does give us the exact same thing as if we typed them into the calculator. So either way works. And lastly, we have this here. And again, if you want to have a feeling that's going to be the case, we can plug them into the calculator. Now the first one's a 2 by 2, 9, negative 8, 15, 21. Second quit, second matrix. Over to edit, matrix B is a 2 by 2. 2. There we go. 7, 18, negative 21. Okay. Show me where it is. Negative 21, 2. Second quit. Now the first one says that we're multiplying the first matrix by negative 2 So we have negative 2/3 second matrix A. And we're adding to that 3/5 times second matrix B, enter, and we get this here. Negative 9/5, 242/5, negative 113/5, and negative 64/5. And that would be the final answer for this one here. Now that does bring us to the last three questions on this here. Write the equation of a line and find, I'm going to also say find the slope, but we need to find the slope to be able to find the equation of a line. Now if we look at this here, we are given 2 points. One of them is at the origin 0, 0. The other is at 133. So if I want to find the slope, we'll just use the equation y2 minus y1 over x2 minus x1. Well, one of our y values is 33, the other is 0. Now 33's corresponding x value is 100, so it has to go first, and the other x value goes second. Now at this point here, we could plug this into the calculator, and it tells us that it's 33 over 100. And we can use that as the slope. And to find the equation of a line, now that we have the slope, we're going to use y minus y1 is equal to m times x minus x1, our point slope form. Now we do have the slope, it's 33 over 100. And the point we can use is either one of these here. I'm going to use 100 comma 33. So 33 would be our y, 100 would be our x. So we still have y minus 33 is equal to, we can distribute the 33 over 100. Well, 33 over 100 times x is 33 over 100x. Now if we need to, we can do 33 over 100 times 100, which is 33, and it would be negative. Now at this point here, we can get y by itself because we do need to get y by itself to have the equation of a line. So we add 33 to both sides. Those will cancel, telling us y is equal to 33 over 100x. Well, negative 33 plus 33 is 0. So we have our slope and equation of the line. And that's all we need to do for this here. We don't need to interpret the slope or describe the slope. We just need these two pieces here. Now we have our next one here. Now the first thing we need to do is find the slope. Well, our slope is y2 minus y1 over x2 minus x1. Well, our two y values, one of them is 90, the other is 40. So we can do 90 minus 40. 90's corresponding x value, incidentally, is 40, and the other x value is 15. Now at this point here, if we wanted to plug this into the calculator, we could, or we can do it by hand. 90 minus 40 is 50. 40 minus 15 is 25, which tells us it is 2. So our slope is 2. Now we can use the equation of a line. Our point slope form, y minus y1 is equal to m times x minus x1. Now we know the slope is 2, and we just need to pick one of these 2 points. Doesn't matter which. I will pick 15 comma 40. So 40 will be our y value, 15 is our x. Now we just need to solve, get y by itself. So the first thing we can do is distribute the 2, which will tell us that we have 2x minus 30. And the last thing we can do is add 40 to both sides, telling us y is equal to 2x plus 10. So at this point here, we do have the slope and equation of a line, so that's all we have to do for this one here. And lastly, we have this here. Now they specifically didn't give us 2 points, but they did. because it does intersect the y-axis at 0, 65. So we do have another point. And we can use these 2 points to find the slope. y2 minus y1 over x2 minus x1. Well, the 2 y values are 65 and 65. I put this 65 first, so its x value of 5 goes first. So the other x value goes second. Now at this point here, we can plug this into the calculator. Say 65 minus 65 over 5 minus 0 is indeed 0. Because our numerator, 65 minus 65, is 0. And 0 divided by 5 is 0. So that tells us our slope is 0. And that's fine. We can still plug it into point slope form to get our answer. Plug in 0 for the slope and go from there. Now I'm going to pick the point 5 comma 65. So we'll plug in our y value of 65 and x value of 5. Now we solve it for y. So the first thing I'm going to do is multiply by 0. Well, 0 times x is, well, 0. 0 times negative 5 is still 0. The entire right side of the equation is 0. At this point here, we can add 65 to both sides, telling us y is equal to 65. And that's it. That's all we have to do for any of this here. We will be going over this in class either tomorrow or if I reviews this, probably in the leading upcoming days. But that is everything from the review sheet.